In this video, we are going to work on questions 19, 20, 21, and 22, page 21 of the textbook. Question number 19. Find the slope of the tangent to the demand curve dp equals 20 divided by square root of p minus 1 when p is greater than 1 at point 5 and 10. To find the slope, we have to find limit of d of p, which is 5 plus h minus d of 5, divided by h, which is the same as times by 1 over h as h approaches 0. This limit would be the same as limit of 20 divided by square root of 4 plus h minus 10 times 1 over h. Limit of a constant times a function is constant times limit of the function. This gives us 10 times limit of 2 minus square root of 4 plus h over square root of 4 plus h times 1 over h as h approaches 0. To find the limit, we rationalize the numerator of the fraction, which is the same as negative h divided by square root of 4 plus h times 2 plus square root of 4 plus h times 1 over h. 2 minus square root of 4 plus h times its conjugate is 4 minus h, which is minus h. If we reduce the fraction and instead of h put 0, direct substitution method, this limit would be negative 10 over 8, which is negative 5 over 4. Question number 20. It is projected that 10 years from now, the circulation of a local newspaper will be CT equals 100 T2 plus 400 plus 5,000. Find how fast the circulation is increasing after 6 months. We are looking for rate of change of the circulation function with respect to time. The rate of change of CT at t equals 0.5, which is the limit of CT plus h minus CT, and t is 0.5, c 0.5 plus h minus c 0.5 divided by h as h approaches 0. To find this limit, we simplify the numerator. If we factor 100, the numerator would be 1 plus h plus 4 after reducing that, after factoring h and simplify, reduce the fraction by h. And this limit is 500. As h approaches 0, limit of 1 plus h plus 4 is 100. It is 5, and 5 times 100 is 500. Therefore, the circulation is increasing at the rate of 500 paper per year at t equals 6 months, which is half a year. Question number 21. Find the coordinates of the point on the curve f of x equals 3x2 minus 4x, where the tangent is parallel to the line y equals 8x. We are looking for a point at which the slope of the tangent line is 8. The slope of the tangent line is limit of f of x plus h minus f of x divided by h as h approaches 0, which is limit of 3 times x plus h to the power of 2 minus 4 times x plus h minus 3x2 plus 4x divided by h as h approaches 0. We assume the coordinate, the x coordinate of the point that we are looking for is x, and we found the slope of the tangent line at x. We expand the numerator and we simplify it as usual. By doing this, the limit would be 6x minus 4. When two lines are parallel, their slopes are the same, therefore 6x minus 4 must be 8. The slope of this line is 8. From here, x is 2. Therefore, the point is 2 and f of 2. F of 2 is 12 minus 8, which is 4. This means at P, 2 and 4, the tangent line is parallel to y equals 8x. Next question, question number 21. Find the point on the graph of y equals 1 over 3x3 minus 5x minus 4 over x at which the tangent line is horizontal. A line is horizontal when its slope is 0. Therefore, we are looking for a point at which the slope is 0. The slope of the tangent line is limit of f of x plus h minus f of x divided by h as h approaches 0. We assume the x coordinate of the point that we are looking for is x. This limit would be the same as limit of 1 over 3 times x plus h to the power of 3 minus 5 times x plus h minus 4 over x plus h minus 1 over 3x3 plus 5x plus 4 over x times 1 over h. Instead of divided by h, I wrote again times 1 by 1 over h. We need to do some algebraic manipulation. You have to take the common denominator and also expand x plus h to the power of 3, which is x3 plus 3x2h plus 3xh2 plus h3, and simplify this. To make it easier, we split it to two limits. One of them is the polynomial part of the function, and the other part is the fraction parts. If we expand x plus h to the power of 3 and times it by 1 over 3, we have 1 over 3x3, 1 over 3x3, and 1 over 3x3 get cancelled. 3x2h times 1 over 3 is x2h, and if we divide it by h times it by 1 over h, we have x. 3xh2 times 1 over 3 is 3. 3 and 1 over 3 cancel each other, is xh2 divided by h is xh. We have 1 over 3 to the power of h3 divided by h, or times by 1 over h, which gives us 1 over 3 times h2. Minus 5x and 5x cancel each other. We have negative 5h divided by h is negative 5. plus limit of 4 over x minus 4 over x plus h. Common denominator is x times x plus h. Then negative 4x and 4x, when we take a common denominator, get cancelled. We have 4h on the numerator. 4h times 1 over h gives us 4. In this part of the course, we haven't worked on the properties of limit that tells us the limit of addition of two functions is addition of limits. But it is understandable that we can divide the functions in two parts and find each limits. The first limit is, as h approaches 0, is x minus 5. And the second limit is 4 over x2. Therefore, the slope of the tangent line is x3 minus 5x2 plus 4 over x2. We are looking for the points on the graph of the function at which the tangent line is horizontal. Therefore, x3 minus 5x2 plus 4 must be 0. To solve this equation, we have to factor. If we split negative 5x2 to negative 4x2 and negative x2, we'll see this polynomial can be broken down to x2 minus 4 times x2 minus 1. If we solve the equation, x would be plus minus 2 and plus minus 1. Therefore, at points negative 2 and 28 over 3, negative 1 and 26 over 3, 1 and negative 26 over 3, and 2 and negative 28 over 3, the slope of the tangent line is 0. F of 1 is negative 26 over 3. If we plug in 1 into the function, we'll see f of 1 is negative 26 over 3. F of 2 is negative 28 over 3. Since the function is odd, f of x, f of negative x, and negative f of x are the same, then f of negative 2 is opposite of f of 2, and f of negative 1 is opposite of f of 1. Thanks for watching.